I am SHAN ANUSHKA, and this is the assignment of DevOps 2020 July batch. The topic is the 7 key factors to secure your DevOps practice. First, we need to know about the DevOps methodology. So what makes DevOps different? The first one is speed. DevOps philosophy takes the principles behind agile methodologies to a new level of speed by increasing the rate at which code is pushed to the repos and subsequently released into production. The adoption of continuous integration tools such as Jenkins enables ever faster releases. The application releases cycle are moving from a few releases each year to weekly releases or even more frequently. The second one is scale. DevOps supports system with 100,000 of applications built by 100 of developers that run on dozens of servers that can increase from 10 to 100 in seconds. When speed and scale become such an important factor, dev teams naturally respond by introducing as many optimizations as possible to eliminate bottlenecks in the SDLC. Very often, the security activities in the software lifecycle are deprioritized or overlooked. After all, we cannot blame for giving up. After seeing a list of hundreds fails positive that sometimes code review tool produce. Then we need to know about what is DevSecOps. DevSecOps, also known as SecDevOps, is a software development philosophy that promotes the adoption of security through the entire software development lifecycle. DevSecOps goes beyond a single tool or specific practice, but generally speaking, it favors security, automation, communication, and scalability. The development philosophy scope includes all teams involved in the SDLC, such as development, operations, and security. In the past, the assessment and validation of the security of the application happened only at the very end of the project. The release cycle were longer, such as months and years. So the postponement of security was not ideal, but it was manageable to some extent. However, the acceleration of the software release cycle has made these legacy development approaches impractical. Enforcement of security was not ideal, but it was manageable to some extent. However, the acceleration of the software release cycle has made these legacy development approaches impractical and even inapplicable. Nowadays, it is not uncommon to release new code to production on a weekly and daily basis. This means that security automation and scalability are required and are no longer optional. DevSecOps favors the inclusion of application security activities from the very beginning of the development stages. Automation is therefore key to allow this agile methodology. Awareness and security culture should be the first priority, but certain AppSec tools will make this security automation easier. Let's have a look on DevOps versus DevSecOps. DevOps is a software engineering methodology that unifies the development and operations activities with the goal of enabling agile continuously delivery. Generally speaking, teams that adopt DevOps practices experience productivity and performance metrics improvements and release better quality software. The other benefits are time to market reductions, application stability increases, increased agility to response to competitive shifts. On top of these DevOps benefits, DevSecOps introduce security automation as well as new security process wrapped around the DevOps flow. For instance, the most basic implementation starts by adding DevSecOps element to the CI/CD pipeline. DevSecOps does not just add security elements, but when done properly, it makes security an integral part of the entire process from the beginning to the end. As a consequence, the security team becomes much more engaged with the rest of the teams involved in the SDLC, including development and operations. This removes frictions as the natural tension between speed and security is shared by all. So, this is the business benefits of DevSecOps. Adopting DevSecOps often delivers immediate business benefits. The first is a general improvement in the security position of the application. As DevSecOps favors early indication and migration of security risk, this also means faster time to market and as a result reduction of development cost. In order to have a smooth adoption of security automation culture, we can recommend a few essential DevSecOps best practices to get started. The first one is short and frequent development cycles. Incorporate security from the very beginning. Leverage technologies that foster agility such as containers and microservices. Make an organizational priority to install a culture of proactive collaboration between the teams involved in the SDLC. Automate security as much as possible to facilitate agile development. Let's move on to DevOps security pain points. The first one is insufficient SAST tuning and false positives. Static AST tools are the most widely used solution in terms of detection of security issues during the development phase. However, SAST tools usually require tuning processes to integrate with each different development architecture, and they present a high rate of false positives. Many developers find the long and static reports produced by SAST tools frustratingly and ignore them. In consequence, SAST tools consuming tuning time for the tools and review time to clean false positive from real vulnerabilities. Dynamic AST tools are also extremely popular, but they lack source code visibility and in turn they present a very low detection rate of existing vulnerabilities. It's like 18%. Also, the detected vulnerabilities are not matched to the location in the code and many of them remain undetected. The second one is lack of coordination between Inforce team and developers. Security issues are treated separately from other software quality issues. QA and penetration testers typically produce long static reports that contain the security issues. As a result, developers must check different systems to review traditional functionality bugs versus security issues. Developers naturally tend to resolve functionality bugs first, and only after they focus on security issues. This means that many security issues are not fixed during development. Once a critical issue sneaks into production environment, it takes an average of 129 days to get fixed. The third one is continuous development chaos. Teams do not have an efficient way to evaluate the security level of their applications, and as a result, security issues sneak into production. Source code compilation issues stop builds and continuous integration pipelines, but there is no automatic way for security bugs to block the development to production. This means that teams must manually ensure the compliance of security, which introduced delay and the development of insecure applications. The fourth one is manual pen testing becomes a bottleneck. First of all, it is important to note that detection solutions only detect one kind of vulnerabilities, essentially code syntax issues, also known as security bugs. Example of security bugs are SQL injections, XSS, etc. And they follow specific patterns that are exactly the same across all applications. Unfortunately, there is another important group of security vulnerability: business logic flaws or design flaws. They cannot be detected by tools. We are talking about security vulnerabilities such as access control, binding, abuse, etc. In view of this situation, and because automatic detection tool only detects security bugs, it's about 50 of the total problem. Companies and organizations perform manual review to detect business logic flaws. Current agile development methodologies that generate new releases almost every day do not adapt well to this manual review. Even when review budgets are not an issue, the review impacts severely on the time to market of your application. The fifth one is poor visibility of security track record. Teams lack access to smart tools to monitor the evaluation of security vulnerabilities from build to build. Most teams are not aware of the number, severity, and age of the vulnerabilities. Fixing all the security issues is next to impossible, but teams lack a clear way to rank the existing vulnerabilities by their severity. As a result, teams waste time fixing issues that are not exploitable, with leaving serious issues unresolved. The sixth one is lack of cloud support. Cloud environments do not have a permittery that can be defined with traditional tools such as WAFs. Cloud providers and development conditions can change dramatically over time. Most security tools do not adapt to these changes. Frequently, security defense is trusted to an edge boundary that has no context, has no visibility of the app. The data flow is only inspected at one point, which limits the security analysis accuracy and introduce false positives. The last one is systems that are not scalable. External AST review strategies such as testing as a service introduce lags in the development phase, ranging between 4 and 24 hours. This lag reduces scalability and increases the time to market. Once in production, it is common to abruptly scale from 10 servers to 100 servers within seconds. DevOps teams complain that security tooling is a bottleneck and lack flexibility to scale dynamically as the application load grows. So these are the 7 key steps to the DevSecOps solutions. The application security community has reacted to the challenges and pain point described above by wrapping the DevOps philosophy with a security blanket. So DevSecOps is all about increasing speed and productivity by introducing automation, monitoring, and tight integration of security. DevSecOps leverage secure SDLC tooling, and at the same time it ensures that the cadence of releases is not hampered. In subsequent posts, we are going to cover in detail each of the following 7 best practices of DevSecOps success. The first one is insufficient SAST tuning and false positive. The solution is use an IAST tool. Most software development teams do not have dedicated to security expert. As a result, security protections will be implemented by non-specialists. Including AST tools in your tool chain empowers developers to create secure code. To avoid the lack of accuracy and the labor-intensive reviews of SAST reports, use use a more direct detection tool such as interactive IAST. Tools do not require tuning or manual reviewing of false positive since they do not generate them. So use the OWASP benchmark coverage indicators to rank vendors with the help of IAST tools. You can remove low code scanning activities and instead receives real-time information on your security issues as your code. IAST tools helps to push security testing left. So the second pain is lack of coordination between enforced teams and developers. The solution is integrate security issues with your general bug trackers. Communicate the bug tracking tools that your team is using such as Jira with your security tools so that developers can see security bugs as regular tasks. Automatically create a new bug and task to represent security vulnerabilities as they are found during the reviews and audits of the application. The goal behind this recommendation is that developer never have to leave their continuous integration and or continuous development toolchain environment. As a result, more security issues are resolved during the development phase, which is much better than resolving them later in the process. The third pain point is continuous development chaos. For this, we can give this solution: define metrics and threshold to assure quality. The same way code compilation errors stop by development, security issues should block the development as well, known as security controls. These automated checkpoints ensure that the code pushed downstream the CI/CD streams respect security standards. Create automatic security checkpoints to enforce quality goals and stop the pipeline if the number of security bugs is higher than a goal. Seek solutions that integrate with your deployment server, such as Jenkins. It is important to adapt the threshold to the team's maturity regarding security, starting with more flexible threshold and using very strict threshold at the end. The fourth pain point is manual pen testing become a bottleneck. Solution is automate protection of business logic flaws. Business logic flaws, also known as design flaws, are an important group of security issues that detection tools cannot identify. To migrate the bottleneck of manual reviewing business logic flaws, automate the input validation using solutions and architecture that are secure from the start. Create feedback loops to help pentest focus their energies on the right part of the application, and when the pen testing team has a clear image of the attack surface, they are more productive. Then integrate the output of the solution with the audit tools. The combination of automating the protection and connecting the protection with audit tools allows automation of most manual pen testing activities. The fifth pain point, poor visibility of security track records. Better reporting is the solution. So the versioning your releases should not be an afterthought. implementing metrics and reports that track the evaluation number and the severity of bugs for each release, enhance solutions such as Jenkins reports and web reports to include security issues, identify metrics that increase the productivity of development and remove critical issues first, and instill a culture that incentives progressive reduction of the number of security issues and celebrates positive improvements trends towards the perfection, and an artifact such as development descriptors and build scripts should be subject to strong version control. Post-mortem analysis should include report with security issues as well. Lack of cloud support is 6th pain point, and the solution is embedded security. Build application with agile security built in when the development conditions and cloud providers change all the time, and applications that have security embedded are able to adapt to the change. So we believe in security as code and vulnerabilities as defects. By incorporating security early in the development process, your application are born secure and remain secure wherever they go. And the last one, systems that are not scalable, and linear scalability and affordable cost is the solution for this, and ensure that the security infrastructure is in your application is not a performance bottleneck. Seek security solutions that scale in constant or linear time, and monitor the evaluation of the added latency of the security solutions, and choose those that perform better. So thank you.